Good morning, everyone. Welcome to my YouTube channel for Kangaroo Medicine Science Academy. I believe you are all well. Today, I will take you through the Euclidean geometry for grade 11, which is also asked also in grade 12. So it means this video is relevant for both grade 11 and grade 12 students. All right. Without wasting time, let me take you through the Euclidean geometry, particularly on the theorems. We're not going to prove the theorem. What I'll just do is just to remind you about all the grade 9, grade 9, grade 11 theorems. We'll start with the first one. The first one is called perpendicular bisector theorem. After the perpendicular bisector theorem, we'll move on to the midpoint chord theorem. Then after the midpoint chord theorem, we'll move on to the angle as the center theorem, angles subtended by diameter, angles in the same segment, opposite angles of a cyclic quad, exterior angle of a cyclic quad, tan chord theorem, and two tangents from the same point of contact out by the circle. So this is what these are actually the theorems that are actually examinable in proving of riders. But in terms of just proving the theorems, I will actually explain which ones are actually examinable when they just asked you to prove them. All right, without wasting time, let's start with perpendicular bisector theorem. Right, according to the perpendicular bisector theorem, it states that a line that is drawn from the center of the circle, a line drawn from the center of the circle, perpendicular to the chord, bisects the chord. What does the theorem say? It says whenever you have a circle, and in the circle, you draw a line from the center of the circle. So you have a circle, there is our circle. Okay, within this circle, okay, let me just draw it nicely. Okay. Oh, sorry. It's fine. So it says a line drawn from the center of the circle. So let's call it the center O. The theorem states that if you draw a line from the center of the circle, perpendicular to the chord. So this is our chord. Let's call it chord AB. I believe you are all able to identify which one is a chord, which one is the radius. I think you must know the parts of the circle. For example, a chord, it's a line that is joining 2 points on the circle by not passing through the center. But a straight line that is joining 2 points on the circle by passing through the center, we know it's a diameter. So according to the theorem, it says a line that is drawn from the center of the circle, perpendicular to the chord, perpendicular to the chord. Here we have a chord AB, and we have drawn a line from the center of the circle, perpendicular to the chord, which means where the line and the chord intersect, there is an angle of 90 degrees. If this is true, a line that is drawn from the center of the circle, perpendicular to the chord, then the line bisects the chord. That is according to the theorem. And it means that if OC is perpendicular to AB, then AC equals to CB. That is according to the perpendicular bisector theorem. Remember, this is true if a line is drawn from the center of the circle. Then it intersects the chord, but where they intersect, then there's an angle of 90 degrees perpendicular. Then it means that line bisects the chord. The line bisects the chord, which means from A to C, is equal to from A to C is the same as from C to B. That is according to theorem number 1. And we know when you want to prove this theorem, you have to use congruency. Congruency. Actually, I don't want to prove the theorems, but I just want to guide you on how to prove this theorem. So to prove the theorem, remember in most of the cases when you are proving the theorem, you must have a required to prove. That there must be a construction if applicable. Then you start with the proof. So in this one, it means if you want to prove the theorem 1 by using congruency, we need to, under construction, we need to join line OA and also join line OB. And we specify these two triangles to say in triangle OAC and triangle OBC, what are the conditions that makes these two triangles to be congruent? So I believe you can prove that. Number 1, we know OA equals to OB. The radius, remember, radius, it's a line that moves from the center of the circle to the circumference, to the part of the circle. If you draw a line from the center of the circle to the part of the circle, which is the circumference, that line is actually a radius. And all the radiuses are equal. So actually, I don't want to prove the theorems now. I just want to use them. Then it means there will be another session where we'll just prove the theorems. Right, then this is according to perpendicular bisector theorem. Then the second theorem, which is the midpoint chord theorem. Midpoint chord theorem. Ladies and gentlemen, these are one of these theorems are important, especially when you're in grade 11 or when you're in grade 12. If you want to enjoy Euclidean geometry, you need to be able to understand these theorems. And they're actually easy. Right, the second theorem says a line drawn from the center of the circle. It's actually, this theorem, it's actually the converse of the first one. It is the converse of the perpendicular bisector theorem. It says a line drawn from the center of the circle to the midpoint of the chord, then the line is perpendicular to the chord. You see, it's the converse of the first theorem. Which says, if we have the center and we draw a line from the center to the midpoint of the chord, a line drawn from the center of the circle to the midpoint. What do you mean by midpoint? Remember, we know a midpoint is just a point that divides a line into 2 equal parts. So if we say C is the midpoint, it means from A to B is the same as from C to B, to B, yes. I'm saying A to C is equals to C to B because C is the midpoint. Do you see that this is actually the converse of the first theorem? Because this theorem says a line that is drawn from the center of the circle to the midpoint of the chord, the line is perpendicular to the chord. So it means now we want to prove that there is an angle of 90 degrees here, which is actually a converse of the first theorem. So this theorem says if from A to C is the same as from C to B, then it means the OC is always perpendicular to AB. Remember, only when a line is drawn from the center of the circle. That is according to the theorem. And we still use congruency to prove this theorem. Theorem, the midpoint chord theorem, ladies and gentlemen. So it's very important to know the theorem. It's very, very, very important to know the theorem. Right, then we're going to move on to theorem 3, which is angle at the center theorem. And this is one of the most important theorems. Angle at the center theorem. Let's just go through this theorem. According to this theorem, it says an angle subtended by an arc at the center of the circle is very important. So let me draw the circle here. Here it's our circle, guys. Let's say on the circle, remember you must know the parts of the circle. We have an arc, which is the curved part of the circle, which is actually part of the circumference. We have a chord, we have a diameter. So it's very important. We have the radius. So these are the terminologies behind Euclidean geometry. You need to know them. I believe you know them. Right, let's say we have an arc here. Let's call this arc AB. So here is our arc AB. So according to this theorem, it says an angle that is subtended by an arc at the center. What do you mean by subtend? Subtend just means formed from or produced from. So in other words, we can say if we have an arc AB and this arc AB subtends or form an angle at the center, so let's call this, we can just calculate angle O1. You see that this angle, it's an angle that is coming from an arc. It's subtended by an arc, but it is at the center. This theorem says if there is an angle that is at the center, which is subtended by an arc, then that angle, you find that we still have another angle at the circumference. An angle subtended by an arc at the center is twice or is double the angle subtended by the same arc at the circumference. And what does this mean? It means that if we have two angles, ladies and gentlemen, one is at the center and one is at the circumference, but those two angles are coming from the same arc or they're subtended by the same arc. Let me form another angle here. Okay, no, okay, it's fine. Let me just try to, maybe let me reduce the size of my angle. Let me also reduce the, okay, apologize. All right, let's construct our angle. Okay. So we have an angle here. Let me join it. Still the same, okay? So we have our O1 here, but we still have another one. Let me construct there. Okay, I think it will be easier this way. Okay. Then we form another one. Okay, apologies, guys. Okay, so let's call this angle C here. So according to this theorem, it says an angle that is subtended by an arc at the circumference. The angle which is subtended by an arc at the circumference, remember this is our arc, can be an arc or a chord. An angle subtended by an arc at the center is twice the angle subtended by the same arc at the circumference. So this theorem states that if you have an angle at the center, which is actual O1 here, and this angle is subtended by an arc, and you find that you still have another angle which is at the circumference of the circle, and that angle is also coming from the same arc, then it means the angle that is at the center is twice the angle at the circumference. Angle at the center, twice the angle at the circumference. Remember, guys, it does not have to be in this format, in this shape. As long as you have two angles, one being at the center and one being at the circumference, and all coming from the same arc, then that angle that is at the center is twice the angle at the circumference. That is according to the angle at the center theorem. So it can also be in this form. We can have something like this. A circle. Within the circle, we have an arc. Let's call it arc AB. So we have AB as our arc. Then within this arc AB, we form an angle at the center. It's just an example. Let's say this is our center. We form this angle. And you find that we still have another angle at the circumference, but coming from that arc. So it means the angle that is at the center must twice the angle at the circumference. Only when it is at the circumference. Angle at center, twice the angle at the circumference. And to prove this theorem, actually, you need to use exterior angle of a triangle. You need to use the exterior angle of a triangle. So exterior angle of a triangle, followed by the issue of isosceles triangle. Isosceles triangle, that in an isosceles triangle, remember in an isosceles triangle, the triangle where two sides are equal but not equal to the third one. And we know if two sides are equal in an isosceles triangle, even the opposite angles subtended must also be equal. Equal sides, equal opposite angles. So we will be using this. It's very important to be able to know this. So if sides are equal, it means even the angles that is subtended by those sides are also equal. Equal sides, equal opposite angles subtended. But we'll talk about that. We'll talk about that when you're going to prove the theorems. So now let us move on. Angle at center, twice the angle at the circumference. It's very important. And guys, this is the easiest of them all. Euclidean geometry, it's one of the easiest because the proofs are not changing. So, but you need to make sure that you practice as many questions as possible. Now, we're going to move on to theorem 4. Theorem 4, it states that angle subtended by a diameter or angle in a semicircle. Actually, we can say angle subtended by the diameter at the circumference. It's a right angle. Angle subtended by a diameter at the circumference. It's a right angle. Angle subtended by a diameter at the circumference, by diameter at the circumference, it's a right angle. At the circumference, it's a right angle. At the circumference, it's a right angle. And what does it mean when we say it's a right angle? It means it's equal to 90 degrees. So the theorem says, I believe now you understand the word subtended. The theorem says whenever you have a circle, and within the circle you have a diameter. I believe you know what is a diameter. A diameter is a line passing through the center. It's a line joining 2 points on the circle by passing through the center. So if we say this is a diameter, it means somewhere it must have the center. So let's say we have a diameter, let's call it diameter AB. According to this theorem, it says if you have a diameter and you form an angle, or you find that there's an angle that is being formed from the diameter, but it is at the circumference. It is at the circumference. It means it has touched the part of the circle. Then you must know that that angle is always equals to 90 degrees. So the angle that is subtended by a diameter, it's always equals to 90 degrees. It is equals to 90 degrees if AB is a diameter. So it's very important to understand that. Angle subtended by a diameter, it's a right angle. Then we also have a theorem 5. Theorem 5 is much related to angle at center, but it's not exactly the same. Theorem 5, it says that angles in the same segment at the circumference are equal. or you can say angles subtended by the same arc. Angles subtended by the same arc or a chord at the circumference are equal. The angles that are subtended by the same arc at the circumference or the same chord at the circumference are equal. What does this mean? It means that when we have a circle, and on that circle you find that we have an arc. It can be an arc or it can be a chord. Does not matter. So within that arc, if we draw an angle, or you find that there are angles that are coming from that arc, or that are being subtended from the arc. So if we draw, let's say we form an angle at the circumference, there, you see it's not at the center, it's now at the circumference. It must touch the circumference. Let's call this C. And we also form another angle from the same arc, also at the circumference. Let's call it D. At the circumference, means it must touch. So you see that we have two angles here that are coming from this arc. We have angle C and we have angle D. They're all subtended from the same arc. So according to this theorem, it says if you have an arc which is subtending two angles at the circumference, those angles are actually equal. Angle C equals to angle D. The reason is that the angles in the same segment, or angles subtended by an arc AB at the circumference. It's also fine. So you need to know this, guys. Right. Then now we're going to move on to Theorem 6, which is opposite angles of a cyclic quad theorem. According to Theorem 6, it states that opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. What does it mean by supplementary? We know supplementary means they add up to 180 degrees. Angles that are supplementary, it means they're adding up to 180 degrees. Supplementary means add up to 180. Then for enrichment, complementary means add up to 190 degrees. But it's not what we want to talk about now. It's just for enrichment. Right. According to this, it says the opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary, and this is one of the easiest when you are proving it for examination. And it's one of the examinable theorem, especially in grade 12. Examinable theorem. So I can also, okay, fine, I'll talk about it later. So according to this, we must understand what do you mean by a cyclic quad. A cyclic quad is just any four-sided figure. So if we have, let's say, a figure, say a quadrilateral is a four-sided figure. Then within this quadrilateral, let's say we have a four-sided figure is a quadrilateral. Then within this quadrilateral, then we draw a circle. And the circle must touch the vertices of the quadrilateral. I apologize, guys. As long as the circle being drawn touches the vertices of the quadrilateral, then it's called a cyclic quadrilateral. It's called a cyclic quadrilateral. So according to this theorem, it says if we have a cyclic quadrilateral, you must know that angles that are actually opposite to each other must always add up to 180 degrees, which means that angle A combined with angle C is equals to 180 degrees. And also angle B combined with angle D is equals to 180 degrees. So in other words, if we are just given a four-sided figure, and we actually want to prove that this is a cyclic quad, it means we want to prove that there's a cycle. If we get this angle here and we get this angle here, if we add them together, they give us 180, then we know there's a cycle here. So it's very important for you guys to understand these theorems. Even if you do not know how to prove for now, but understanding what you're doing, it will be easier for you to answer the questions. Opposite angles of a cyclic quadrilateral are supplementary, which means they add up to 180 degrees. Sometimes in the exam, they will not tell you that you are given a cyclic quad. So it is you who should look on the diagram or on your rider and check whether you are having a cyclic quadrilateral or not. Right, now we move on to theorem 7. Theorem 7 states that an exterior angle of a cyclic quadrilateral, is equal to the opposite interior angle. I want to explain this, guys, because most learners, especially when they are using this theorem, they tend to incur a lot of mistakes. That's some misconception behind some of these theorem, especially on most learners. According to the theorem, it says, if you have a four-sided figure, must listen to me very well. And within that four-sided figure, you find that there is a straight line that is being extended, a straight line that is being extended from that quadrilateral. Let me just say, I'm extending it maybe from here to there. You see, this is a straight line being extended. I'm not talking about when it's like this. You cannot talk about exterior angle in that. I'm talking about a straight line that is being produced from that quadrilateral, not this. So you need to be careful. So now, what does this mean? It means that if you have a four-sided figure and there is a line that is being produced, there's a straight line produced on that quadrilateral, and there is a circle passing through. There is a circle passing through that quadrilateral. Then let me construct the circles. Okay. Right. Okay, so let's call this A, B, C, and D. And if you think this C, you'll realize that we have two angles. We have C1 outside and we have C2 inside. I want to explain this theorem, guys, so that it will be easier for you when you're answering questions. According to the theorem, it says an exterior angle, the angle which is outside that cyclic quad. So this is our exterior angle. It's our exterior angle. So the exterior angle of a cyclic quad must be equal or is equal. Actually, the exterior angle of a cyclic quad is equal to the opposite interior. What does it mean? It means, now, listen to me very well. C1 is an exterior angle. C2, it is an interior angle, but it's actually the adjacent of C1. So what you do, we look at C1. C1 is an exterior. But C2, it is the exterior, is the interior angle of that cyclic quad. Now, what is the angle which is opposite to this interior angle? It's actually angle A. So it means that the exterior angle is equal to the opposite interior. It's equal to the angle that is interior, but opposite to the one interior, which is angle A. So it means that angle A1 is equals to angle A. And this is not examinable as a proof, because it's one of the easiest actually. It's not examinable as a proof. So it means the angle, the exterior angle, but we use it when we answer, when we are solving problems, but just to prove it in the exam, they're not going to ask you that. It's not an examinable proof. But you just know how, you must know how its application. So the exterior angle of a cyclic quad is equal to the opposite interior. So you look at the exterior, then after exterior, you look at the interior, the adjacent of that C1 is C2. And what is the opposite? The angle opposite to C2, it's angle A, which means angle C1 is equal to angle A. That is according to the exterior angle of a cyclic quad. I believe you are following. I believe you're following. Then theorem 8, and guys, this is very important. You know, theorem like the opposite angle, I'm saying the angle at center theorem. When we talk about angle at center theorem and the tan chord theorem, these are very important, guys. You know why these are very important? In most of the cases, for example, if you want to prove angle subtended by diameter, you need to know angle at center theorem. If you want to prove angle in the same segment, you need to know angle at center theorem. If you want to prove opposite angles of a cyclic quad are supplementary, you need to know angle at center theorem. You see that angle at the center theorem and also tan chord theorem. It's one of the most important theorems that are actually examinable in the paper. So you need to know how to prove them. But in terms of the proving, we'll talk about in the next session. Then now, let me talk about the tan chord theorem. Tan chord theorem. This is very important, guys. Tan chord theorem. As long as you know what you are doing, even if you forgot how to prove the theorem, but once you're able to recite them or be able to use them in solving riders, you're good to go. This is one of the easiest, both in grade 11 and 12. Remember, if you're in grade 12, you need to know this theorem, especially when you're going to deal with similarity triangles. Similar triangle, similarity. You need to know these theorems. Very important, guys. It's very, very, very important. Right, let's talk about tan chord theorem without wasting time. Tan chord theorem states that an angle between a tangent and a chord, an angle between a tangent, an angle between a tangent and a chord, an angle between a tangent and a chord drawn from the same point of contact. Drawn from the same point of contact. An angle between a tangent and a chord drawn from the same point of contact is equal to the angle. Very important. It's equal to the angle subtended. It's equal to the angle subtended by the same arc. So let me say, by the same chord in the alternate segment. In the alternate segment. You need to recite this. You need to know this actually. You must understand them. An angle between a tangent and a chord. The angle that is been formed between a tangent and a chord, this is according to the theorem, drawn from the same point of contact is equal to the angle subtended by the same chord in the alternate segment. That is according to this theorem. Let me talk about it. According to this theorem, it says that whenever you have a circle, whenever you have a circle, let's say you have a circle, and within this circle, you find that you have a tangent. Remember, a tangent is a line that touches the curve not once, not just a circle, but a curve. A line that touches the curve once, it's called a tangent. Then how about a line that touches the curve more than once? What is it called? A line that touches the curve once is called a tangent. How about a line that touches the curve more than once? More than once. What is it called? Obviously, it's called a secant. It's a secant. A secant. Right. According to this theorem, it says whenever you have a tangent, and within that tangent you draw a chord. Let me just say chords, actually. So here it's a chord. Remember, a chord is just a line joining 2 points on the circle without passing through the center. So that's our chord. That's also our chord. Okay. Okay. Let me try to reduce this other one. This side. Okay. So these are our chord. And there is the chord. Okay. Right. I apologize. Okay. Then now, let's give this name. Let's say this is A, point B, point C. Now, let me, okay, on point C, we have three angles. We have C1, we have C2, we have C3. Apologize. Right. First of all, let me just give these names and let's call this, okay, this one is, we know it's a tangent. This is a chord, AB. It's a chord. Even AC is also a chord. Even BC is also a chord. Right, let us go through the theorem. It says an angle between a tangent, an angle that is between a tangent and a chord. Let's trace the angles that are between a tangent and a chord there. Tell me, look at the angles, which angles here are between a tangent and a chord? Obvious, the angle that is between a tangent and a chord, the first one is C1. C1, it's an angle between a tangent and a chord. C1, because this one is a tangent. Oh, it's a tangent and this one is a chord. So C1 is an angle that is between a tangent and a chord. How about C2? It's between two chords, so it's not what we're talking about. And how about C3? C3 is also an angle between a tangent and a chord. C3 is also an angle between a tangent and a chord. Right, let us go through the theorem. It says whenever you have an angle that is between a tangent and a chord, drawn from the same point of contact. You see that the tangent and the chord are being drawn from the same point up here. Then you must know that the angle is equal. That angle must be equal to the angle subtended by the same chord in the alternate segment. What does this mean? It means that because C1 is between a tangent and a chord ABC, then that C1 must be equal to the angle that is coming from the chord BC, but not this side where there is our angle, but in the alternate segment, this side. So what does this mean? It means that we are controlled by our chord, the chord which is formed between the chord which forms that angle C1. So it means that the name of the chord that is forming angle C1 is BC. And what is the angle that is subtended by this chord? Actually, it will be angle A. So which means angle A is equals to angle C1. That is according to the tan chord theorem. So it means that even angle C3 will be equal to the angle B, because angle B it's subtended from the chord AC. So it means angle B it also equals to the tan, it is equals to C3. Remember guys, this is one of the most important theorem when you're proving rightness. Very important, very important. Then the last one for grade 11, it is the two tangents from the same point of contact. So this theorem states that two tangents from the same point of contact outside the circle are equal in length. The theorem says whenever you have two tangents that are drawn from the same point of contact outside the circle, those two tangents are actually equal in length. And to prove this, we use congruency. So it means improving theorems using congruency. We're using the first theorem, perpendicular bisector theorem, we use congruency. Midpoint chord theorem, we use congruency. And two tangents from the same point, we use congruency to prove those three theorems. So according to this theorem, it says whenever you have a circle, and within that circle, you draw a tangent. And on the other side, also, you have a tangent. As long as these two tangents are drawn from the same point of contact outside the circle, then those two tangents are actually equal in length. Their length is equal. Those two tangents are equal in length. That is according to this theorem. It means from this point, let's say this is A, this is B, this is C. As long as they're drawn from the same point of contact, it's from A to B, the same as from B to C. It means we use this theorem when we have two tangents. Two tangents drawn from the same point of contact outside the circle are equal in length. That is according to this theorem. Now, the question is which theorem are actually examinable as proofs? The theorem that are examinable as proofs, the first one is the perpendicular bisector theorem. Number one, this is examinable as a proof. So you must be able to know how to prove theorem one using congruency. Theorem two, midpoint chord theorem, it's also examinable. Theorem three, angle at center, it's also examinable. So it means 1, 2, 3. Then this one, it's not examinable. They just ask you to. We just use it when you're solving riders. Even angle in the same segment is not examinable. Opposite angles of a cyclic quad, examinable, this one. Exterior angle, we use it in the riders. Tan chord theorem, it's examinable. Tan chord theorem, it's examinable. You must listen to me. Proving, when proving, if they say prove a theorem, but not in terms of application. Applying, we use all the theorem. But proving, we use those 5 theorems. So that's why in most of the cases, they like tan chord theorem or opposite angle of a cyclic quad or angle at center theorem. But I'm not saying that you must not prove these two. You have to know their proofs, which we'll talk about it in the next session. I believe, guys, you are following. All right. Kindly don't forget to subscribe, to like and share. Okay, and also hit the bell button for future video notification. Okay, right. I believe, guys, you are well. Let's go and let's deep dive into the to the questions. And okay, I forgot something. Before we deep dive into the questions, I just want to give you some tips on how to actually answer these questions when you are given when you are given a rider. So here are the tips of solving riders. Number one, if you read the question and they tell you that O is the center of the circle, this is very important. They tell you that O is the center of the circle. There are 5 things that you should look at when you are given O the center of the circle. Number one, you must look for what is called radii. Radii means it's more than 1 radius. Right, this will lead you to what is called the isosceles triangle. We know that an isosceles triangle is a triangle where 2 sides are equal. If 2 sides are equal, then even the opposite angles, the angle that are opposite to those sides are also equal. So which is equal sides, equal opposite angles. That is according to the isosceles triangle. Why do we have to consider radius? Remember, all the radius are equal. All the radius are actually equal. All radius are equal in a circle. So that's why if the radius are equal, those radius might form an isosceles triangle. So you need to know that. The second one is to consider angle at the center theorem. I think I spoke about that. Because in the angle at the center theorem, there's an O, the center. And you must also consider at the angle subtended by a diameter, because where there's a diameter, usually there's a center. Angle subtended by diameter is equal to 90 degrees. We spoke about that. And you must also consider perpendicular bisector theorem, which is theorem 1, which we spoke about that. Why? Is because it also have all the center. Line drawn from the center of the circle, perpendicular to the chord, bisect the chord. And the last one, you need to consider the midpoint chord theorem. So these are the 5 things that you should look at when you are given the center of the circle. Then how about you are told that 2 lines are parallel? When 2 lines are parallel, you must always think of the word fun, very important. Fun. F-U-N, which states that when you have an F shape, then the corresponding angles are always equal when the lines are parallel. So these are corresponding angles. Then the co-interior says if 2 lines are parallel in a U-shaped form, then this angle and that angle are not equal, but they're adding up to 180. Then also have alternate angles that says when you have an N shape or a Z shape, as long as the lines are parallel, then the alternate angles are equal. So it's very important to know this. Either it's a ZN or a Z. As long as lines are parallel, then this angle and that angle are equal. So it means even if they say prove that 2 lines are parallel, you check the shape. If it's in a form a Z shape, so it means if you found that this angle and this angle are equal, then it means these 2 lines are actually parallel. It's alternate angles equal. But if you are in grade 12, whenever they gave you parallel lines, you must also think of proportionality theorem, which we'll talk about it. Because the proportionality theorem also uses lines that are actually parallel, because it says a line drawn parallel to one side of the triangle divides the other 2 sides in the same proportion, or divide the other 2 sides proportionally. So if these 2 lines are parallel, then we can say AD over DB equals to AE over EC, or we can play around. This is particularly for grade 12, proportionality theorem, not for grade 11. So these are the things that you should look at when you are solving riders. Then the third one, it is when you are given a cyclic quad. When you are given a cyclic quad, you must consider 3 things. Number 1, opposite angles of a cyclic quad are supplementary. I think I spoke about that. Or the exterior angle of a cyclic quad is equal to the opposite interior, or also angles in the same segment or angles subtended by the same arc. So it means when you are given a cyclic quad, you must look at the shape, whether it is closed. If it's closed like this, it's a closed figure with a circle. If it's a closed figure with a circle, then you must look for the opposite angles are supplementary. But if it's just a closed figure with a line being produced from that, then you must look for exterior angle equals to opposite. But if it's forming something like this, usually I call it a zigzag form. It can be closed or not closed, but as long as you have something that is, if you, this angle and that angle must be equal, and this one and that one must be equal. It's angles in the same segment whenever you have a cycle. Even if they say prove that this is a cyclic quad, you must check. If it's like this, then you prove that opposite angle are supplementary. If it's like this, it means you're proving that exterior angle must be equal to the opposite interior. If it's like this, must prove that angle in the same segment are equal. If angle in the same segment are equal, then it is a cyclic quad. I believe you are following. Then how about when you are given a tangent, guys? When you are given a tangent, as long as they say something is a tangent, you must look for 3 things. 3 things, very important. The first one you must look for, it's an axiom, it's not a theorem, which says that wherever there is a tangent and a radius, as long as they're drawn from the same point of contact, there must be an angle of 90 degrees. There must be perpendicular. And we use this is very important, guys, especially in analytical geometry. So the tangent perpendicular to radius is not a theorem, it's an axiom. So right, then now, tan chord theorem, we spoke about it. Two tangents from the same point of contact, we spoke about it. So it means all the time, or the center of the circle, you must look for 5 things. So it's 5, it's 3 things, 3, 3, 1. So when we are given chords that are equal, it's also an axiom which says equal chords, equal angle subtended. If two chords are equal, let's say we have chord AB, and this chord AB subtend this angle at the circumference, let's call it C. And also have another chord here, let's call it DE. And this chord subtend an angle at the circumference, let's call it F here. As long as these chords are actually equal, it means the angle that are subtended by those chords are also equal. So equal chords, equal angle subtended. Equal chord, equal angle subtended. Because, and also it can be chords or it can be arc. Because if arc are equal, even the chords must be equal. So it can be equal chords or equal arc. There's no problem with that. I believe, guys, you are following. Euclidean is one of the easiest paper, and you can get good. Remember, it has a lot and lot of marks, especially in grade 12, guys. You need to make sure that you spend more time on Euclidean geometry. Remember, practice makes perfect. The only way to understand math is to practice. Right. Now, let's move on to the riders. Actually, I'll just, due to time, I'll just look at one question, then the other one will do it. All right. Then now, let us look on this question. This is a Limpopo 2016 prelim paper. Okay, let's look on the statement. And guys, one of the things is in terms of Euclidean geometry, the best way is to know that you don't have to look at the questions. Look on what you're actually given. All the answers are on the statement given here. Once you know what you're doing, then it will be easier for you to understand. Okay, I believe, guys, you are following. I believe you are following, guys. Okay? Okay, just a minute. I want to check something. Okay, then the first one says the vertices of triangle. The vertices of triangle, that if you're talking about the triangle, the vertices of triangle P, from P to N and R lies on the circumference. It lies on the circumference. So they're just telling us that point P and R and N and R, they are points on the circumference, but it's not the only point that is on the circumference. Even angle S, it's on the circumference. Right, we'll talk about that. We'll talk about that. And then now, another thing very important there is that when you are given this, okay, guys, just a back, welcome back. I apologize. Just a minute. Okay, so as I was saying that P, N, R, and S are points on the circumference. Already you can see that we have a cyclic quad because there are 4 points on the circumference. We have a cyclic quad. And I want to talk about that later. Let's talk about that later. On the circumference of the circle O, on the circumference of the circle O, this is what I wanted to talk about. I want us to go through those tips. Number one, we're told that O is the center of the circle. Number one, O, the center. What did I say about when proving riders? When we were given O, the center, I told you about 5 things. Number one, Radi, you must look for Radi. Why Radi? Radi can lead you to an isosceles triangle. Let us go through. Remember, a radius is a line that moves from the center of the circle. A line that moves from the center of the circle to the circumference, it's a radius. Obvious, we have radis here. The first one, from O to N, this is radi. And from O to R, it's also a radi. And from O to S, it's also a radi. And what do I say? All the radius are equal. All the radius are equal. Let's check. Remember, I can also say O what? OR equals to OS equals to ON. What is the reason for that? There are Ds. So we have radi, but let's check. Does this radius forms an isosceles triangle? Yes, we have an isosceles triangle, ONR. ONR is an isosceles triangle. And we know that in an isosceles triangle, as long as 2 sides are equal, it means the angle opposite to those sides are also equal. So obvious, you can see that in triangle ONR, angle R3 equals to angle N2. What is the reason for that? Equal sides, equal opposite angles. Equal sides, equal opposite angles. The sides are equal. It means the angle opposite to those sides are also equal. It is the only radi we have here. I'm saying it's the only isosceles triangle we have. Unless if I miss something, but I did not miss something. So angle R3 plus angle, I'm saying angle R3 is equal to angle N2. It's equal sides, equal opposite angle because of radius. So I believe you are now following. Let's move on. I want us to follow whatever I said. Number 2, we need to look for angle at the center theorem. Angle at the center theorem. Okay, let me use angle at the center theorem. Then after angle at the center theorem, we'll look at the angle subtended by diameter. Number 4, okay, let me just write them in that order. Okay. So angle subtended by diameter. Okay, angle at the center. Let's first identify any angle that is at the center. When I check O actual on OO, they labeled, we have angle at center. It's actually this angle here, O1, if I'm not mistaken. O1 is an angle that is at the center. So let's look at the name of the arc that is coming from this center. It is our SN. And you see that since the angle O1 is an angle at the center, it must trace which angle? Remember, let's trace the angle that is coming from this arc. From this arc, if we trace the angle, we can get that SN is subtending angle P1. P1 is also coming from the same arc. So we can say angle O1 twice angle P1. Reason is that it's angles at the center theorem. Angle at the center theorem also, it is the applicable one. Another one, it's not the only one. Look at angle P1. I'm saying angle R3. R3 also, this angle here. It's also an angle that is coming from the same arc. So it means even O1, it's also twice angle R3. Angle at the center theorem. Angle at the center theorem. But now we still have another angle, but unfortunately it's not labeled. So I don't know how it means. If it's not labeled, it means, yeah, we can use it. We can use it. Let's just use it. Look at the whole of R angle ON. From R to O to N. R angle ON. R from R to O. From O to N. The whole of this angle, it's also an angle at the center because subtended by N and R. And let's go and trace the name of the angle that is coming from that NR at the circumference. It will be P2. So we can say N angle OR or R angle ON is twice angle P2. Still angle at the center theorem. Angle at the center theorem. Let me just say, yeah, it's still the same reason. Angle at the center theorem. I believe, guys, you're following. Right, then now another one, it is the issue of angle subtended by diameter. Remember I said you must look for the 5 things. Angle subtended by diameter, angle subtended by diameter. We know an angle subtended by diameter is equals to how much? 90 degrees. And guys, it's very important to understand what we mean by diameter. A diameter should be a straight line. Not when two, we know diameter is equals to radius, but this is not the diameter. ON and OR are not the diameter, it's not a diameter. From NOR is not, because it's not a diameter. A diameter should be SOR. SOR is a diameter. SOR is a diameter. Why? Because it is a straight line. And according to the theorem, it says an angle that is subtended by a diameter, it's always equals to 90 degrees. Okay, guys, I apologize, just a minute. Okay, guys, I apologize. Okay, right. As I was saying that an angle subtended by diameter is equals to 90 degrees. Which one is the diameter here? SOR is the diameter because it's a straight line. So what is the name of the angle that is coming from that diameter? If you put your fingers, one on S and one on R, you trace the angle that is coming from this but touching the circumference, you'll get angle P1 plus P2. So which means angle P1 plus P2 is equals to 90 degrees. Angle P1 plus angle P2, or the whole of P, is equals to 90 degrees. Then number 4, we need to look for perpendicular bisector theorem. What does the theorem say? It says a line that is drawn from the center of the circle. A line drawn from the center of the circle, perpendicular to the chord, bisect the chord. Do we have such line? Yes, there is a line that is drawn from the center. There's a line drawn from O to W, but we are not told anything about whether W1 and W2 is 90. So since we do not have, we are not told that W1 and W2 is 90, then we do not have it for now. Unless if we prove that W1 and W2 is 90. Means we do not have that. And there is another line that is drawn from the center of the circle to the chord PN. If you look at PN, PN is also a chord. So a line drawn from the center of the circle to the chord It's there, but we do not, T1 is 85, it's not 90. So it means we do not have that. Also, we do not have midpoint chord theorem. So it means we're not going to talk about the last two. Unless if we prove. So we do not have perpendicular bisector theorem and the midpoint chord theorem. So we'll do away with those two. Unless if there's, when we are continuing, then we are going to get that. So we are done with the issue of or the center. Then the second one they said is diameter SR. Diameter SR, as I said, already we spoke about that, about a diameter. Diameter SR, we spoke about it. Then there's no need to continue that because I've included it already there. And chord NP, diameter SR and chord NP, the intersected T is true. The intersected T. And now, and you must know this is from grade 10 that when two lines intersect, you must have vertical opposite angles. So this angle and that angle must be equal, and that one are equal. You see that already within this where the line is intersected, T1 and T4 are equal. And T3 and T2 are equal. I believe you know these basics. Okay, then we are told that R2 is 30 degrees. Angle R2 is 30 degrees. Angle T1 is 85. We are given that. Angle T1 is 85. So let me write the information here. Because we'll be using this in solving riders. Right, let me write the information here, ladies and gentlemen. So T1 is 85 degrees. R2 it's 30 degrees. Okay, this is the given information. Right, again, we're told that RK is a tangent. RK is a tangent. RK is a tangent. What are the three things that you should look at when you're given a tangent? I think I spoke about that. Number one, you must look for tangent perpendicular to radius. Right, obvious, we have a radius from O to R, it's a radius. And RK is a tangent. So you see that the tangent and the radius are intersecting. So it means there should be an angle of 90 degrees. So it means that if we take R1, we combine this with R2, then this will give us 90 degrees, tangent perpendicular to radius. Even R3 plus R4, it's also equals to 90 degrees. And remember, if we actually wanted to answer this question, since we know that R2 is 30 degrees, what would be R1? Obvious, R1 will be 60 degrees. R1 will be 60 degrees. Okay, then another one is the issue of tan chord theorem. Tan chord theorem says an angle between a tangent and a chord must be equal to the angle in the alternate segments obtained by the same chord. Okay, let's first identify the angles that are between a tangent and a chord here. Obvious, PR is a chord. PR is a chord. PR is a chord. And since PR is a chord, then what is the angle between tangent and so it's R1. So I'll say R1. R1 is an angle between a tangent and a chord. And what is it equals to? We look at the chord. What is the angle subtended by the chord? I think it's two angles. This chord PR is subtending angle S. And it's also subtending angle N, the whole of angle N at the circumference, which means angle R1 equals to S. And it's also equals to NN. Let me just write it like this. So R1 equals to S and it's also equals to N, which means R and N are equal. And it's true when you're going to talk about cyclic chord. The reason is tan chord theorem. I believe you guys are following. What is another angle that is between a tangent and a chord, guys? Another angle between a tangent and a chord is R4. R4. So R4 is also an angle between a tangent and a chord. Because this is a tangent, this is a chord. What is the name of the chord? NR. So what is the name of the angle subtended this chord NR at the circumference? At the circumference, it's P2. So it means angle R4 equals to angle P2. It's tan chord theorem. Tan chord theorem. I believe you guys are following. But it's not the only one. There is another one also. Look at angle R3 and R4 combined. They're all 90 because we got P1 plus P2 is also 90. Look at R3 and R4 combined. R3 and R4 is still by the way, this is not a chord, sorry, but they're equal. It's not a chord. Okay, fine. Then now we're gonna move on. So we got this. So it's about the tangent, tan chord. By the way, number 3, 2 tangents from the same point is not there. Why? Because we have 2 tangents. We do not have 3 tangents. We only have 2 tangents. So we spoke about the center of the circle. The center of the circle, I think we mentioned it. Because the diameter is also part of. Tangent also we looked at. Then now, let us look at this. Sometimes, remember, they will not tell you. How many points are on the circle, guys? 4 points. So we have a cyclic quad. There is a cyclic quad. And since there is a cyclic quad, what type of this cyclic quad are we having? Is it closed? Remember, cyclic quad can be in 3 forms. It's either they're like this, or they're like that, with a line produced, which is the exterior angle, or they're like this. So let's look at the format. Is it like this? No, it is not closed. If it was closed here, then we're going to apply it to use the first one. So it means we're not going to use this first one. And because of that, we're not going to use the first one, and we're not going to use the second one. So obviously, it is the angle in the same segment, which is equal. So I'm going to say P what? I will have to say P, PR, and PS and R is a cyclic quad. And the way it is a cyclic quad, it means since we're not going to use opposite angle as supplementary and the exterior, so it is just angles subtended by the same arc, because the theorem says angles that are subtended by the same arc in the circumference are equal. Let us go arc by arc. Okay, if you look at arc P, is it an arc or chord? Arc PR. What is the name of the angle that is subtending this arc PR? It's angle S and angle N. So we're going to say angle S is equals to angle N. What is the reason? Angles subtended by the same arc. Angle subtended by the same arc. You must specify the name of the arc PR. Or you can say angles in the same segment. Angles in the same segment is also relevant. Another angle, obvious, SP, it's an arc but it's subtending only one angle. We're not going to talk about it. Let's move on to another arc, SN. SN also, with SN, what is the name of the angle subtending angle SN? Let me say, what is the name of the angle that is subtending arc SN? The name of the angles that are subtending arc SN, it's angle R3 and angle P1, if I'm not mistaken. Yes, R3 and P1. So it means angle P1 and angle R3 are equal. So I'm going to say angle P1 equals to angle R3. R3 and P1 are equal. Also, the angles in the same segment. Angles in the same segment. Angles in the same segment. So now, since we have analyzed our diagram, remember some of the things you can still calculate them by looking at this. Then from there, we can just give the reasons thereafter, especially on the information given. For example, let's say we're told that R1, what is R1 here? And you must also know that exterior angle, you must know the properties of the exterior angle of a triangle because the opposite interior. You must also know the sum of angles in the triangle add up to 180 degrees. So some things are just straightforward. For example, if Okay, let's just say, I don't want to erase anything here. Let us look at the question. What does the question say? It says, determine the size giving reasons, stating reasons, the size of S. If you want to get the size of S. And if you want to get the size of S, obvious, angle S equals to angle R1, according to the Tan-Code theorem. Angle S equals to angle R1, according to the Tan-Code theorem. So which means that to get angle S, we can get angle R1. We can get angle R1 first. Or another way, we can do this. Angle S, it is in triangle SPR. So if we take angle S plus P, the whole of P plus angle R2, this must also add up to 180 degrees. So sum of angles in a triangle add up to 180 degrees. So we can still get angle S1. I mean to say S. So there are many ways to skin a cat. So it means one can say, since we know, it means if we're answering that question, we're going to say angle P1 plus angle P2, it's 90 degrees. Reason its angles in the same segment. Angle in the semicircle. Or angle subtended by a diameter. So we know this angle is 90. If this angle is 90, here we are given is 30. So we're going to say angle S plus P1 and P2 combined plus R2. This must add up to 180. Reason? Sum of angles in a triangle. So we want angle S. This one we know it's 90. This one we know is 30. So we can get that angle S. So 90 plus 30 is 120. So 180, so this will be 60 degrees. So this angle will be 60 degrees. But it's not the only way. The only way one can say, another one can use this property. R1 plus R2 is 90. It's another way you can say R1 plus R2 is 90. Reason is the tangent perpendicular to radius. So we know R2 it's 30, so it means the R1 will be 90 minus 2, which will be 60. But we know that R1 and S are equal according to Tan-Code theorem. So you see that angle S will still be 60 degrees. So whether you use this approach or there are many ways to skin a cat, I believe you understand. So angle S, it's 60 degrees. Angle S, it's 60 degrees. Angle S, it's 60 degrees. We got it. Whether with the first method or there are many ways to answer the question. Okay, then we have answered that angle S, it's 60. So what is the next question? Okay, let me raise this because already we know that angle S is 60. Okay, what is the next question? The next question is that one of, then it says, with reason determine size of R3, guys. How are we going to get R3? Right, in order to get R3, we can get R3 in many ways. We can do this. Look at the triangle where there is R3, guys. R3, it is in a triangle T and R. If you look in triangle T and R. Okay, let me just say in triangle T and R. I'm referring to this triangle here. That's why we have R3. In triangle T and R, We know that sum of angles in the triangle must add up to 180. Already, we have T1. T1 is 85. Which means if we get angle N, the whole of N, which is N1 plus N2, then we'll be able to get R3. And it's easier. Look, there's something we said here. We said angle S and angle N are equal. S and N are equal because they're angle in the same segment. When I'm talking about N, I'm talking about the whole of N1, N1 plus N2. The whole of this angle is cos the whole of that because they're all coming from the same arc or chord. So they're equal. So which means the whole of N1 plus N2 combined is 60. N1 plus N2 combined is 60 because this one is also 60. So I'm going to say this is 60 and that is also 60. So I will say angle N is equals to angle S, which is equals to angle is 60 degrees. What is the reason? Angles in the same segment. But I also say in triangle, what is the name of the triangle? Let's specify. In triangle NRT, if we take T1, we combine with the whole of angle N. We combine with R3. This will give us 180. And T1 we already know it's 85. T2, I'm saying angle N is 60. Then we can get angle R3. By getting angle R3, it means we have to transpose 85 and 60 to the right-hand side. So we can transpose 85 and 60 to the right-hand side, and that will give us 35 degrees. So R3 is 35 degrees. R3 it's 35 degrees. Another way would be, that's what I'm saying, there are many ways to skin a cat. We can look at this triangle here, this triangle here. If you look at this triangle PTR, from P to T to TR, R to P again. If we get P2, then we can be able to get R4 because R4 and P2 are equal according to the Tanquist theorem. And once we get R4, then we're going to get R3 because R3 plus R4 is also tangent perpendicular to radius. So what we're going to do, can say, oh, okay, fine. T1 is an exterior angle in this triangle. Or another way would be, if we don't see that, T1 and T2 are on a straight line. So we can get T2 by saying 180 minus 85. So which means T2 is 95. This angle here, it's 95. Why 95? Because 95 plus 85 is 180. If you don't want to use the exterior angle of a triangle. Then since T2 is 95, if we take angle T2 with angle P2 with angle R2, this must add up to 180. So what does it mean? It means 180 minus 95 minus 30. Then P2 will give us, will be 55 degrees. And if P2 is 55 degrees, we know that angle R4, according to this, angle R4 is equal to P2. Which means since P2 is 55, it means R4 it's also 55. But according to the tangent perpendicular to radius, we know that if we take angle R3, we combine it with the angle R4. R3, combine it with angle R4. This must give us 90 because it's tangent perpendicular to radius. So it means that since we know R4 is 55, so the R3 will be 90 minus 55. So it still will be 35 degrees. You see, there are many ways to skin a cat. It will be 35 degrees. It will be the same, 35 degrees. So we got the value of R3 it's 35 degrees. Okay. Right. Then now let's continue with the questions. Okay, this one is just, I want to leave the ones that I just summarized. Because if we wanted to use, let me check another one. Okay, fine. What is the next question then? We got, we answered 1.1.1, 1.1.2. Now we have to go through 1.1.3. 1.1.3, it wants us to determine angle N1 only, just N1. Now, let us go through the question and try to answer the question for the size of N1 with reasons. First of all, let's go to our triangle and our rider and look or identify where we have N1. N1, it is in triangle ONT. N1, it is in triangle ONT. Which means that if we want to get angle N1, we must know angle O1. Because T1 already have. So you see that since if we get angle O1, we'll be able to get angle N1. Because sum of angle in the triangle add up to 180 degrees. Or another way, if we get N2, it will be easier for us to get N1. They're still applicable. But N2 we know, because if we know R3 is 35, it means N1 is also, N2 is 35, because equal sides, equal opposite angles. So it's another way. But yeah, the best way is to just get O1. Now let's go to what we summarized and identify where we have N1. Let me say O1. O1 is twice angle R3, that is here. So we're going to say angle O1 is twice angle R3, which is the angle at the center theorem. Okay, but O1, we do not know O1. What do we know? We know angle R3 is 35. We just calculate it. 2 times 35, this guy gives us 70. So it means angle O1 here, it's 70 degrees. And since we know T1 is 85, then we can get N1 by saying, remember, N1 plus T1 plus O1 must add up to 180. So it will be N1 equals to 180 minus 70 minus 85. So that will give us the size of N1. Reason is that sum of angles in a triangle add up to 180. I believe you are following. So which will give us 25 degrees. It will be 25 degrees. Practice makes perfect. It's not the only way. It's not the only way. We can get N2 first, because N2 and R3 are equal. It means this one is also 35. But angle, the whole of this angle plus the whole of this angle plus T1, it's also 180. You can still do it like that. It will give us the answer. I believe you guys are following. I believe you guys are following. So angle N1 is 25. And remember, N1 plus N2 must add up to 60. 25 plus 35 is 60. All right, what is the next question? The next question wants us to determine R4. You see, already if it wants to determine R4, in that other method we used, we already got R4. Because R4 is equals to P2. I think I've explained it already. R4 is equals to P2, which is Tan-Code theorem, which means if we know P2, we can get R4. We can still do that. We can still do that. By the way, what was the size of P2? Oh, by the way, I was relating, R4, the size of R4, it's how much? It's 55, yes. R4 is 55. I think we spoke about that. R4 is 55. So I've answered that. Then the last one says, determine whether NT is a tangent to the circle. And this is very important. Determine whether NT is a tangent to the circle through N, O-R, NT. Oh, they're saying we need to prove that, to prove whether is NT. This NT, whether NT, where is NT? That's NT. Whether NT, it is a tangent to this circle that is passing through N, passing through O, and passing through R, if I'm not mistaken. Let me check. I think it's what they said. Yes, NOR. Yes. So to prove that, it means we want to prove if this one is a tangent, if NT is a tangent, ladies and gentlemen, it means here we're supposed to have a circle here. And if we want to prove that this is a tangent, it means we have to prove that angle N1 is the same as angle R3. It says whether. So it means we are not proving that is a tangent. We are proving whether it's a tangent or not. So it means for this to become a tangent, it means angle N1 and angle R3 must be equal. N1 and R3, they must be equal. If they're not equal, then it's not a tangent. And yes, it's not a tangent. Why? Because angle N1, we got it to be what was it? We got to be 25 degrees. And angle R3, we got it to be 35 degrees, if I'm not mistaken. Yes. You see that angle N1, it's not equals to angle R3. N1 and R3 are not equal because one is 25, one is 35. So it means NT is not a tangent to the circle passing through N, O, and R. It's not. If it was a tangent, this angle here was supposed to be equal to this one. So this one is 35. I think we spoke about that. This one is 55. Hope you understand. 55. So it's not a tangent. Okay. So now let's move on to the next question. But because of time, guys, I will leave you to do this one, the next one. But I just want to guide you. There's one thing that I did not talk about. That I want to talk about the issue of parallel lines. Remember, practice makes perfect. Okay, next session. In the diagram below, KT is a tangent. I think we know what is it that we must do when we're given a tangent. Tangent, three things. Number one, tangent perpendicular to radius, but this one is applicable when we have a center. Number two is the tan-chord theorem. Number three is tangent from the same point of contact. But here we have one tangent, so we're not going to have that. So since we have this, let's look for, do we have a center? There's no center, so it means we look for tan-chord theorem. Let's look for the angle between the tangent and the chord. I think it's K2. K2 is between a tangent and a chord. So what is the name of the angle subtended from this chord? It is M2. So we're going to say K2 equals to angle M2. If I'm not mistaken, the reason is the tan chord theorem. Okay, we do not have tangent perpendicular to radius because we do not have the center. Another tan chord theorem is not there. Okay, fine. Then it means this is the only thing we got. The other one, it says to the circle at K, it's parallel to the chord, or the line KT is parallel to the chord. And guys, very important, if they say the line is parallel and you find that it's on like a line like this, you must also put the parallel line here. So we are told that this line and this line are actually parallel and parallel. So we know when we are given parallel line, we must always think of fun. Number one, let's check. Do we have an F shape here? Because of those lines that are parallel. This line and this line are parallel, we do not have an F shape. U shape. Yeah, U shape is there, but in most of the cases we do not use it. Then how about Z or N? Yes, the Z is there. From K to T, T to N, N to M, there's a Z. So it means angle N1 and angle T are equal. Angle N1 is equals to angle T. What is the reason? Alternate angles. And you must be careful, guys. Alternate angles such that you must pick the conditions such that KT is parallel to an M. Do you have another Z? Yes, we do. We do. From K to K, from T to K, K to M, M to N. So K1 plus K2, angle K1 plus angle K2 is equals to M1. Reason it's also alternate angles such that KT is parallel to NM. But since we know K1 plus K2 is 84, so it means even this angle is also 84 degrees. Okay. I believe, guys, you are following. Then another condition is that, okay, NT cuts the circle at L. Okay, fine. Then triangle KML is drawn. Triangle KML is drawn. No, so angles in the triangle add up to 180. Angle, what is this angle? Okay, angle M2 is 40. They told us that angle M2 is 40. M angle KT is 84. Okay, fine. So now let's look on the other thing. Okay, here we're not given all the center. Do we have a cyclic quad here? Do we have a cyclic quad here? Yes, we do have a cyclic quad because there are 4 points on the circle. And according to this 4 points on the circle, it's not applicable to opposite angular supplementary because it is in this form. Okay, I apologize, but it's in that form. So you can see that here we look for angle in the same segment. Let's start with arc ML. If you look at arc ML, this arc ML, it's subtending which angle at the circumference? Obviously, it's subtending K1 at the circumference and N. So which means these two angles are equal. Angle K1 equals to angle N1. Reason is angles in the same segment. Another one, if we cannot move arc by arc, because if you look at arc KL, it's just subtending one angle. So let's look at arc KN. What is the name of the angle? What is the angle that is subtending this arc? At the circumference, it will be L2, and it will also be M1. So it means angle M1 equals to angle L2. Reason it's angles in the same segment. It is the only one, is that one we have. So without having to look at the question, by just analyzing this, we can still get the answers here. Number one, we're told that K2 is equals to M2 is a tan cot 10, but already they've given us M2. M2 is 40. So it means even K2 is also 40 degrees. So K2 is also 40 degrees. And if K2 is 40 degrees, we know K1 plus K2 is 84. K1 combined with K2, it's 84. So you see that since we know that K2 is 40, it's 40, we can know K1. So 84 minus 40, this will become 44. So it means K1 will be 44. Yes. Because this one is 40. And if K1 is 44, we know K1 and N1 are equal. So it means even this one is 44 degrees. Reason it's angle in the same segment. But again, K1 plus K2 is equals to M1. So it means this M1, it's 84 also. Because K1 plus K2, it's 84. And if K1 plus K2, it's 84, M1 is 84, even L2 is also 84, because L2 is equals to M1, angle in the same segment, so it's 84. So you see that we can get L1 by using sum of angles in the triangle. But we know that angle N1 and angle T are equal. So it means it's alternate angles. So if N1 is 44, it means even T is 44. You see that we can also get angle 3. So there are many ways to skin a cat. I believe, guys, you're following. I believe, guys, you are following. You're following. So if we look at the questions, the first one says, determine the size of K2. You see, K2 already we have. K2 is equals to 40 because it's tan cot theorem. K2 is equals to M2 is tan cot theorem because M2 is 40. Then it says determine the size of N1. Where is N1? N1 is here. So which means if you want to know N1, we can relate N1 with K1. And it means if we get K1, then it's the same as N1 because K1 already we have because K1 will be 44. 84 minus 40, K1 will be 44. It means N1 is also 44. Angle T. Angle T is equals to angle N1. Alternate angles. So it means N1, T is also 44. L2 is straightforward. L2 equals to M1 in terms of angle in the same segment. And what is our M1? Our M1 already is given, it's 84. Due to alternate angles. Is it alternate angles? Yes. K1 plus K2, yes. It's alternate angles. Then what is this? What is it L2? Yes, L2 equals to M1. Angle is in the same segment. Then the last one is L1. L1 is we're going to use sum of angles in the triangles to get the answer. I believe, guys, you're following. Kindly pause the video and try to solve the questions on your own. And check if you're getting the same answers as the one I got myself. Okay, thank you guys for listening. I think we will meet in the next session, the part 2. But the part 2, it's either I'll talk about the proving of the theorems or I will go to grade 12 theorems. Actually, the applications for grade 12. Yeah, just go through the questions on your own. Yeah, you analyze the diagram. Then after analyzing the diagram, then you answer the questions on your own. Remember, K2 is 40. N1 is 44. T, it's also 44. L2, it's 84. Then L1, sum of angles in the triangles. Okay, thank you, guys. Thank you.